of you might have gotten to the 60 right away. Does it make sense that if it's a third of a calzone, it's the bigger angle? And the bigger angle, for my visual people, is over a little and down a lot. And the over a little would be a negative, ooh, did you figure out negative?
Yeah. Ooh.
Down a lot. Now, not everybody has to go this way, but if you like at all the over a little, down a lot, or if you like the coordinate from the unit circle, this is where you needed to get to. Why are they both negative?
Third quadrant.
Third quadrants have to go left and down. Left makes a negative x, down makes a negative 1. Okay, so I go left and I go down. If you like thinking about it this way, you can label your triangle negative 1/2 and negative root 3 over 2. Then think, how do I find tangent? Opposite over adjacent. Or, if you memorize, y over x. That's a formula too. So if you have the ordered pairs, we made that chart where we said tangent is y over x, or you could think opposite over adjacent. If you did that, opposite over adjacent or y over x, you would have had that this is equal to, now here's where it gets nasty. Ugh. But they're both over halves. Without even multiplying by a reciprocal, dividing a fraction, you say, oh, hey, that's shared. The over 2 is shared. So then all I have to do is say a negative over a negative is a positive, and root 3 over 1 is... Now, cheater chart people. Cheater chart people. Okay? The cheater chart goes sine, cosine, tangent. And the reason it goes in this order is because to get tangent, you take sine over cosine, or y over x, or opposite over adjacent. That's why the order is sine over cosine makes tangent. Now, technically there is 0 and 90. There is 0 and 90, but the tricky ones, like if we're in here in the middle, we're not on 0, we're not on 90, we're in the middle. You can think of 30, 45, 60. Or you can think of pi over 6s, pi over 4s, and pi over 3s. And remember, 1, 2, 3, 3, 2, 1, all over 2. Now here's where the song kind of breaks down. Numerator square rooted, right? Square root of 1 is 1. Square root of 2, square root of 3, square root of 3, square root of 2, square root of 1 is 1. 1, 2, 3, 3, 2, 1, all over 2, and square root of numerators.
Ooh, that doesn't work.
Square root of 3, over 3, 1, square root of 3. If you were able to figure out that this was a 60 degree in the third quadrant, in the cheater chart, 1, 2, 3, 3, 2, 1, all over 2, square root of 3, over 3, 1, square root of 3. Hey, it's this guy. 60 degree. It's this guy. But what's the sign? All students take. The only functions that are positive is tangent and his reciprocal cotangent. All students take. Tangent's positive. Some of you might not have liked the cheater chart until right about now. Does it work?
Yeah.
It's a good one. It's a good one. Luca introduced it to us. Mari already knew it too. Did you know it too, Bethany? Yeah.
Is that a Brazil thing?
Yep. So, we should be thankful, because some of you are like, I like that. Let's use it. 1, 2, 3, 3, 2, 1, all over. 2 in the numerator is square root of 3 over 3, 1 square root of 3. Anyway, what's the final answer to the tangent of 4 pi over 3?
Square root of 3.
Square root of 3.
Yeah.
Positive square root of 3. Okay. Whoa! 9 pi over 4! We should all freak out. Never. Stop.
No, we're good. We're good.
Michael, what are we doing?
Okay, so technically 8 over 4 is a full circle, right? 8 over 4.
Why is 8 over 4 a fourth circle? 2 calzones, 4 there, 4 there. Got
And
it.
then plus 1, don't you go back into the first quadrant?
Did it make sense?
Yeah, I got that.
9 pi over 4. We have 4, 8, 9. Right?
Yes.
We have cut into fourths. We have 4, we have 8, we have 9. Booyah. It's the same thing as who? Pi over 4. If you don't like memorizing, can't you always take a pi over 4? I didn't show this over here, but couldn't you change this 2 degrees if you really wanted to?
Yeah.
And technically, 4 goes into 180 45 times. It always will. And over 4 will always get you to a 45. And the first quadrant, wait, we're trying to find sine. Pause. Cheater chart people. 45 is in what placement?
It's in the pot over.
It's in the middle, right? So, 1, 2, oh, I'm done. Square root of 2 over 2. And I'm done with the problem. That's not part of the song, but that's okay. Right? 1, 2, okay. Square root of 2 over 2. Non-cheater chart people. Go over middle, up middle. It's up square root of 2 over 2. It's over middle, up middle. It's not one of the little or one of the lots. It's not 1/2 and it's not root 3 over 2. Over middle, up middle. That's going to be a square root of 2. My ordered pair people, square root of 2 over 2. Square root of 2 over 2 people. Sorry, people. The sign is the 1. Geometry people. It's a 1, 1, root 2. Opposite over hypotenuse. Root 2 over 2 when you rationalize. Find a way that works. You could use a geometry triangle and do opposite over hypotenuse and rationalize. You could do the over middle, up middle. It's root 2 over 2. You can memorize this and pull out the y. Or you could do 1, 2. Okay. Square root of 2 over 2. Done. Is the unit circle impossible? The answer is no. But will your brains all like possibly very different ways? Yeah. And why was it positive? All are positive in the first quadrant. Jacob.
But on the unit circle, isn't that opposite side 1/2?
Remember, 1/2 is when you go over a little, up a lot. That's going to be a 60-30 or a pi over 4. Or you go over a lot, up a little, that's going to be a 30-60. That's going to be a pi over 6. Pi over 4 is a 45-45. The over and the up are the exact same. It's an isosceles triangle.
But it's only one going up when it's in the middle, right? Like 90 degrees.
See, he's saying.
Oh, I'm sorry. Geometry people, you think about a 45-45, which has 1, 1, root 2 from geometry. It's technically not scaled. Like this is technically my triangle right here, the way I drew, the unit circle would be like down here somewhere. So I'm showing the triangle as you learned it in geometry. To get it inside, you technically would have to divide everybody by root 2. And that's the one that I showed that was littler, where you have root 2 over 2, root 2 over 2, and 1. I was just trying to remind people from geometry it is a 1, 1, root 2 triangle. So I was reminding them of that one. Does that kind of make sense? Some people like having the easier without the fractions because then they can do the fraction for themselves, opposite over hypotenuse, etc. But you're right. In the unit circle, this is what you would have to go over and up. Good question. Any other questions? Okay. We might have a little more of a unit circle competition if we have some time, but let's go ahead and check our evens really quickly. Guys, some of you for the first time right now are like, wait a minute, I think my brain could hold on to this. How many of you guys before coming in were like, oh, I could have solved that one without any discussion with my group? Like a third. How many of you now are like, I think I can figure this thing out if I take a little more time with it?
Yes.
Okay. Are there some of you whose hands are still not up? Maybe it's just you don't like participating, but maybe you need to come talk to me and have me help you find a way that works. I would love to. You gotta come in and give me a chance, okay? You gotta come in and give me a chance. Let's go ahead and check our evens real fast. Great job, kiddos. Because if you guys just noticed, did anybody look around the room and people raise their hands? There were like 3 or 4 hands that were like, I could have done that before the group activity. And that I almost tripled after the group activity. That means that you guys were really productive in your groups. So I want to say good job on that. Super good.
Extra credit?
Here we go. Oh, what?
Extra credit?
3 points.
We love 3 points.
I'm so glad I didn't.
I like extra.
All right, let's read.
I'd rather stop.
Hey. The extra credit will show up when you do well on the unit circle stuff, right? That's where it's going to show up. The points will show up there. The points will show up there. It's not extra, well, it's extra what it would have been a second ago. All right, so here we go. And number 6. It wasn't unit circle stuff. That's okay. It was a y and an x. So we stole the y for the sine, like the formula says. We stole the x for the cosine, like the formula says. We took the y over the x. Do you guys see how the 17s cancel? The y over the x for the tangent. Cosecant, flip sine, secant, flip cosine, tangent. Sorry, cotangent, flip tangent. This one, it wasn't unit circle, but it was still SOHCAHTOA CHOSHA or, if you want to think about it, using the X and Y formulas we wrote down in our notes. Sorry, do you guys get number 4, odd and even? Okay. Number 18, that was unit circle. That was unit circle. Guys, what quadrant? 4 pi over 3.
That's third.
It's naturally in the third, so now let me change it. Negative 4 pi over 3. Well, instead of going positively 1 in a little bit, we're going to go negatively 1 in a little bit. What quadrant are we in? Second. Which is why, second, all students, sign is positive, but everybody else is not.
Oh my gosh.
Sine, steal the y for my coordinate people. Cosine, steal the x. Tangent, y over x. See the little over 2's canceling when you divide the 2 together? Some of you are freaked out about fractions. Hold on, I'm trying to show you this is not too bad if you're doing the quadrant way. Sorry, the coordinate way. If you divide these two, y over x, which is what you would have to do, what happens to these 2's? They just reduce. They both have them. Jacob.
Wouldn't it be negative 3 over 2?
Nope, positive, because the negative 4 pi over 3, I have to go negative 3 pieces and 1 more. I'm in the second
it's
quadrant.
negative 4 pi.
Yeah, right? It flips it all around. Be careful of the sign, it does make a difference. Be careful of the sign of the angle, it does make a difference. Does that work? For my cheater chart people, you just have to get second quadrant to get your signs, but otherwise, it's a 60 degree, so 1, 2, 3, that's the sine. 3, 2, 1, that's a cosine. Oh, what's the one I didn't do today? Oh, so sad. Okay, hold on, pi over 3.
Spider-Man.
Which angle is pi over 3? Well, that's 90. That's pi over 2. That's 0. That's 0.
90.
That's pi over 4. He's in the middle.
This one.
Where's pi over 3? This one. 60 degree, right?
I don't understand this one.
So, remember, for pi over 3, cosine is 1/2. Sine is square root of 3 over 2. Cosine is 1/2. Sine is square root of 3 over 2.
Oh my.
You just have to figure out second quadrant, all students, that one's positive, that one's negative. But remember, cosine 1/2, sine square root of 3 over 2. Okay. What happens when you're on an axis? Go ahead and use the x, use the y, plug into our formulas. Did you guys get when you do 1 over 0, it's supposed to be undefined?
Yeah.
When you do 1 over 0, it's supposed to be undefined?
Anything over
Some of you guys might have gotten a little confused on that. But remember, we steal the y for sine, steal the x for cosine. Tangent, we divide the y over the x, which is 0. Flip 0, it's undefined. Flip negative 1, whatever, 1 over negative 1, still negative 1. Flip 0, it's undefined. Remember 40, did anybody figure out what properties we had to use? This was what we didn't get to really talk about a lot yesterday. I showed you the properties real fast. What did the directions say? I think they told you a hint, didn't they? Use the, this one, number 40, come on. Use the, what did the directions say? Uh-oh, are we not writing them? So you guys are going to be taking off lots of points in our homework practice? Guys, come on, evaluate. Evaluate? Oh, it doesn't say to use the even and odd properties at all? Oh, just use the value? Alright. In our notes it said use the even and odd properties. So I was hoping they would have put that. They just said use the value. AKA they say, well, here's a cosine answer. What's the angle? I don't know. Calculator can find it, but it wouldn't really help. Here's the cosine value. Well, if that's the cosine, what's the sine? Oh wait, they're not asking for sine. What are they asking for? Cosine of negative t and secant of negative t. Kiddos, even and odd properties. Let me pull up the notes real fast. These properties that we didn't get to spend a lot of time on yesterday. Single page, let's go back. Where am I going? I'm going up the wrong way. You guys saw an old pop quiz. It's not going to be our pop quiz. So we're going to do ours with candy. That's more fun. Getting ready for, remember the big one that's coming next week? We have the unit circle quiz before break. It's okay. It's okay. It's going to be like today, but I'm going to give you like 5 of them. Instead of tangent of 4 pi over 3, I'm going to give you like 5 of them and a bonus. You just have to be able to do it. Okay? For Coming back. Well, pause. Last year, I think you had to fill in the whole unit circle.
Yeah.
That's not how your brains all work. So I'm not gonna make you fill in the unit circle.
No, I like it. I like jelly.
Find a way that works.
I'd like to memorize it.
Okay.
I'm right.
Thank you. But remember the whole filling in the unit circle? Some of you liked that quiz last year, but the problem is I asked you how many of you remember how to do it when you got in this year. Not many. No, it's not a thing. Just, you gotta learn it better. You gotta learn it better. Guys, even in odd functions, there are properties that we were supposed to get into our notes. It was right towards the end of class yesterday. But do you see how, look. If we know cosine of t, if we know what cosine equals, shouldn't we also know what cosine of negative t equals? Sine's going to be a little different, as with all the rest of them, but sine's going to be a little different. If I know sine, I have to flip it. I have to make it opposite to be sine of the negative. But if it's cosine, the even property says, oh, if it's cosine, we can keep it the same. So what happened when we took cosine of negative t? We kept it exactly the same. That's all you have to do. The even property says cosine, whether it's of t or negative t, keep it the same. And secant is also even, and he says keep it the same, but wait a minute, we can't keep cosine for secant. Do you remember what the relationship between secant and cosine is? Cosine is x, secant is 1 over x. So what am I going to do this negative 3/4? Keep the negative, but when we do the fraction, gotta flip it. Cosine is x, secant is 1 over x. The negative doesn't matter. They're both even, which means keep the signs the same. They're both going to be negative like the original was. But secant says flip it. If it was sine and cosecant, I would have to make the sign opposite for both of those. But since it's cosine, since it's even, I keep it exactly the same and I just flip it for secant. I think, guys, that's the end, yeah? Of our evens? Oh, number 16. Oh, it's the answer, I forgot. Number 60, I think it made it way harder than it needed to be. What was 60's question?
Do all trig functions exist?
Say one more time.
Do all trig functions, trigonomic functions
Exist. Oh, and that was the graph, right?
Yeah.
Okay. Where did they put that little angle? They didn't give you like an actual angle. They just like drew it. Where was it?
Third quadrant.
Okay. Somewhere over there-ish. Question. We already saw some undefined trig ratios today. What did it take to be undefined? Do you remember? Over 0. So over, okay, these guys could be over, right? Not that you had to write a whole paragraph, but these guys could be over. Well, stink, guys, if an angle is here, is anybody, or is there going to be anything that's a 0 that needs to go into any of those formulas?
The J's.
When are the zeros?
on the axis.
Only when it's at 0 or 90. There's a 0 that shows up in that one and that one. There's a 0 that shows up in this one. I can't write it. -1, 0. And then 0, -1. The zeros only happen when it's on an axis. This guy's not. Oh, they're all fine. They're all fine. Who knows? They didn't even tell us exactly what angle, but who knows? You can even look at pi over 3 and say, oh, there's no zeros. The only zeros happen when it's on an axis. That was the long story short. Don't even erase it. That's the long story short of A and B. I think it was asking for the signs. Guys, in the third quadrant, all students take. What are all the signs? Who's positive? Tangent. Ooh. And who's the other guy that's based on cotangent? So, all students take tangent, cotangent, positive, everybody else negative. That's it. Done, done, done. All right, kiddos. Let me get out of that. If you have any other questions, since we did take some time on the unit circle today, let's go ahead and we got to get into section 4.3. We already did triangles. Let's get rid of that guy.
-1 less than.
Yeah. Since you guys are just now getting out your notes, let me stay on this page for just a second. It was right towards the end of yesterday, and some of you didn't get the even and odd properties down. So hold on, pause. Before you move on from 4.2, double check that you finished 4.3. Sorry, that's backwards. Before we move on to 4.3, let's double check that we finished 4.2. And as you guys do that, prepare for our first candy quiz. No, calculus took all the good ones. Oh, there's still some good ones.
You have Twix?
You don't have Twix, that was gone a while ago. No Kit Kat. 100 grand, York, Milky Way, M&M's, peanut M&M's, Whopper. But what you get is what you get. Make sure you don't throw candy food if you're not ready. Is there a sneeze? Did I miss it?
No.
It's just throwing me off. Yes, if anybody wants to go to Nicaragua this summer, we still have some empty spaces. Nicaragua mission trip, if anybody's thinking about it. Or if you haven't thought about it, there's some cool kids going. Might get Mr. Carmichael, we're trying.
That's a deal breaker.
Christine,
This guy's
Silver
still
loves it.
going.
It's a good place to go.
Yeah, that's, no,
He's the legend.
That's his choice.
Why did I not think about that earlier?
Take it out. It's like saying I want. Take it out.
Go to Spain, do not fill that out, go to Spain, please.
Talk to parents this weekend. Talk to Melanie, be like, sure, go.
Melanie who?
Christine's older sister. Alright, let's see. Question. What is, raise a hand, don't say it out loud. What is cosine of pi?
Oh, shoot. I don't even know.
Like
The value.
the value is -1,0.
What's cosine?
Cosine.
Which one?
Oh,
Cosine's only one of them.
I got you. Oh, -1.
Yes.
no.
Question. What is sine of pi over 2?
Dang it, what do you say?
What is 1?
One.
Because it's up. Sine is up. Question. What is cosine of 5 pi over 4?
Oh, that 2 over 2.
No. Chris.
Oh, sorry, 2 over 2.
No.
Negative, we're at 2 over 2.
Okay, now. All my cheaters.
No, I wouldn't cheat.
All eyes looking at me.
Dang it.
Why was it negative? Not for candy. Why was it negative, Chris?
Because it was in the third
It's in the third quadrant. All students take sine and cosine are both negative in the third quadrant.
Are you okay?
Question. What is cosine of 5 pi over 6?
Square root 3 over 2. Negative 3 over 2.
Oh, just give
Hey,
me
he
a
got
candy.
screwed.
Oh.
Was he right with the negative?
Wait, you said cosine of,
I said cosine of 5 pi over 6. He said square root of 3 over 2. I was like, oh, he said negative. Was he right? What quadrant is 5 pi over 6? How many pieces do you have? All but 1.
so it's.
5 pi over 6. 6 minus 1. Cosine is adjacent over a lot, but it's going left. I need a negative. Or all students. Who's positive in the second quadrant? Sine, not cosine. Cosine's negative, sine's positive. Cheater chart. 5 a 30 degree. 5 pi over 6 is a 30 degree. 1, 2, 3, that's sine. 3, square root of 3 over 2, but a negative. 1, 2, 3, 3, oh, it's a square root of 3 over 2. Last one.
Most of New York.
What is tangent of pi over 6?
For a York, oh, you guys better get this for a York.
Tangent of pi over 6.
I don't like
I'm
that.
looking for any hands. Oh, you don't like it?
I love
I
York.
love this idea.
Take it, just get the answer right.
Come on, AJ already has candy. Anybody else? Tangent of pi over 6.
That's what I think.
No, I don't want to get it wrong.
No.
Don't pick my boy.
Pick my boy.
No.
Oh, you let me down.
Who's that candy?
Square root of 3. I don't know.
No. Anybody, Chris? No.
Oh, not
Who doesn't have
today.
candy yet? Hey.
1 over 2?
No.
Is it square root 3 over 3?
Okay.
Pause. Pi over 6.
Don't be fat, Mike.
Mike has a York. Mike is.
Well, Chris needed it. Like, it was Chris's choice. I can't believe that.
It's
Okay,
just
hold on.
body, it's his choice.
Guys.
Is someone who's
Guys.
It's like nothing.
I like doing candy quizzes as long as we just keep it together. Keep your head in the game. All right. Cheater chart people. This is why I was dying just a little bit. Cheater chart people. A pi over 6. A pi over 6. I was in the first quadrant. 30, 45, or 60?
Oh. 30.
30. Cheater chart people. 30. Tangent is the last one. 1, 2, 3, 3, 2, 1, all over 2. Square root of 3 over 3. That was the answer. Ah,
Why is it over 3?
because if you have 1, 2, 3,
I see it as the triangle.
3, 2, 1. Pause. Pause. How is tangent related to sine and cosine?
Y over X.
Y over X or sine over cosine. So to get this column, unless you like the song and want to memorize it, you can just take this one divided by that one. Jacob, the over 2's cancel. 1 over root 3, I need to rationalize. So when you rationalize, you get square root of 3 over 4. This one divided by that one, the 2's cancel.
Yeah.
So 1 over root 3, but you have to rationalize. That's where we get the square root of 3 over 4. Remember, we're not allowed to have a square root in the denominator.
So you just put it on top.
So we multiply top and bottom by the square root. And then 1 times root 3 is root 3. Root 3 times root 3 is root 9, which is just 3.
Oh my God.
Does that make sense, kind of? But the sum, 1, 2, 3, 3, 2, 1, all over 2. Square root of 3 over 3, don't even have to think about the math. 1 square root of 3. Hey, if it works. But everybody starts with a blank paper and a blank quiz and a blank test, so if they want to write that down, if you want to write down the first quadrant of the unit circle, if you want to write down the whole unit circle, if you want to write down triangles, that's kind of effective. All right, so let's keep going to section 4.5. No, 4.3.
I got this.
Good thing is, we're going to keep working on the unit circle over the next few sections. But you still need to choose for you. Remember what I asked at the beginning of 4.2? Give me a chance to find a way that works for you. But I can't do that if we don't meet one-on-one. So you have to do that. Take what I've given. Take what your classmates have tried to say. Take what finally clicked today if something did. And if nothing did, give me a chance again. Come on in. Let's try to work it through. You have to choose a way that works for you with the unit circle. It's going to keep coming back for the next 2 chapters. 4, 5, and 6. So this chapter and the next 2. It's going to keep coming back, so you got to find a way now. And study that way. And we'll keep doing some candy quizzes for a couple days next week. We'll probably have a unit circle quiz around Wednesday or Thursday. It's just going to kind of randomly come up. We're just going to keep on doing trig stuff. But some of you guys will be like, whew, thank goodness, because what do you see on the screen? A triangle. how do we label a right triangle when talking about its sides? Opposite, adjacent, and hypotenuse. Remember how I told you SOHCAHTOA CHOSHCAHTOA I was cheating and using it early? It's because technically this is the section that we talk about it. SOHCAHTOA CHOSHCAHTOA. SOHCAHTOA CHOSHCAHTOA. And where does SOHCAHTOA first of all come from? Well, I guess you could kind of say that, but kind of not. SOHCAHTOA, sign, equals. Opposite over?
Hypotenuse.
Which came first?
Ka.
Adjacent over.
Adjacent over?
Hypotenuse.
Hypotenuse. Toa, good, keep going. Tangent equals? Opposite over adjacent. Now, I could technically write these 6 trig functions in any stinking order that I wanted, but first of all, I didn't want SOHCAHTOA, sine, cosine, and tangent. But why do these next ones go in the same order, or this order? Like this one it was S and then C, this one's C and then S. What's going on? Why would cosecant be written across from sine? It's that, careful.
Reciprocal.
Good. Opposite means an opposite sign. Cho. Flip sign for cosecant. Secant, flip cosine, hypotenuse over adjacent. They're all reciprocals. And cotangent, adjacent over opposite. Hence where our so, sine is opposite over hypotenuse. Ka, cosine is adjacent over hypotenuse. Koa, tangent is opposite over adjacent, comes from. And sometimes it's nice for me to think about, sorry, Jacob, go ahead.
Is cotangent x over y?
Yes. Yes. So think, take tangent, y over x. Flip it. X over. SOHCAHTOA, I know the fly, just ignore. Cho, cosecant is hypotenuse over opposite. Sha, secant is hypotenuse over adjacent. Tau, cotangent is adjacent over opposite. SOHCAHTOA CHOSHCAHTOA. But wait, that's pretty straightforward if they give us a triangle with all the sides labeled, but what if they give us something super weird like sine of theta equals 0.6? What? I thought sine was a fraction.
Me too.
You still get our calculator.
Wait! 0.6, what is it?
That is a fraction.
Yep. What fraction?
That is 3 over 5.
Can't I say I know the
You can.
sine? So the opposite and the hypotenuse, all I need to know is to finish my triangle, a squared plus b squared is c squared. So I can say, who's that guy? Well, I don't know, I'll go find him. Although some of you guys should already know this one. It's one of those nice geometry triangles.
I don't know the geometry.
Can't remember a 3, 4, 5 triangle?
No.
Technically plus or minus 4, but if we're talking about the measurement of a triangle, we'll just go ahead and say 4. So therefore we can say, how are we going to use that, guys, to solve for what they want, which is cosine of theta and tangent of theta? Well, I have my triangle, no big deal. Who's cosine? Adjacent over hypotenuse, of course. Who's tangent? Wasn't meant to be that hard. Opposite over adjacent, of course. Once you have the triangle, use SOHCAHTOA CHOSHCAHTOA. Guys, this homework is not due until Tuesday. I'm sorry I didn't get the backboard updated. But you do need to work on the unit circle this weekend. Find a way that works for you studying and get started on this homework. I'll see you guys later. Not too bad, right triangles? Thanks, you too. I'm Steve. Bye, Sophia.
wanted straight flow. I'm a basketball player and I work out with Paul.
Bye guys, enjoy tomorrow. Get through today, hang in there.
I was looking at the sheet and it said that the deposit was due yesterday.
I'm gonna charge that also. Go home, see what they say.
Okay, thank you.
You're welcome.
Is there any way I can know how I did on the test I zonated up?
Since it's not a percentage grade on there yet,
Green?
I can show you what the T's are. Guys can't show it that quick.
Thank you.
Yeah. You got it? Joseph, would you mind pausing the recording up there? Do you know what I mean? Hitting the